Suppose x has a mound-shaped distribution, normal distribution, with sigma is equal to 8.1. Find the minimal sample size required so that for 95% confidence interval, so we want 95% confidence, the maximal margin of error is E is 0.3. Okay, now our formula for the sample size is going to be equal to n times z alpha divided by 2. The book uses a little bit different notation than this, but same idea. It's our critical z-score, times sigma divided by e. And all that squared. Well, we're given sigma and we're given e. The one thing we're not given is this critical z-score. Now to find that, we take our normal distribution curve, and we're given 95% confidence. So we put the 95% in the middle. And all of this has to add up to 100%, which means if we put 95% in the middle, I'm going to put 5% into the tails. And it's going to be split up evenly. So if you take 0.05 divided by 2 in your calculator, you're going to get 0.025. So I put 0.025 here and 0.025 here. And again, all this adds up to 100% then. Now our critical z-score we're looking for is right here. And what we're going to use to get that is we use our INV norm function. And it's always based upon the area to the left. Well, here's our value right here. So I'm going to add up all the area to the left, the 0.025 plus the 0.95. So that's going to give us 0.975. So let's see what that gives us. Do second vars, choose INV norm, 0.975. And we'll round this to 2 decimal places. You would get a different answer if you left all the decimal places in there. Your answer would actually be more accurate though. But for purposes of this homework, we're going to round this to 2 decimal places. So now I know what z is. It's 1.96 times sigma, which was 8.1, divided by e, which is 0.3, and then squared. So let's see what that gives us. We got 1.96 times 8.1 divided by 0.3, close parentheses, and then the x squared. And press enter. Now we always want to round up. So this is 2800. So we go to 2801. Now it does not matter what your decimal is. This one we would round up anyway. But it doesn't matter what your decimal is. If you have any decimal at all, you always take this to the next integer. That always ensures you have enough in your sample. So our answer we'd enter into the computer is 2801.